Oh, thank you for coming. About in the year 2010, we accidentally got a avocado farm, and we soon discovered that we wanted to, like you have an avocado farm, you usually have professional people run it. But it turns out the professional people didn't want any part of our farm, so we actually became reluctant farmers. So in the year, somewhere around, I lost the ability to commute to work, so I spent most of my time working on an irrigation system. And I worked on my irrigation system for probably 5 years. And 4 of the years I've worked on it using Redis. And so 4 years, the purpose of this talk is to show my evolution over 4 years and how to use Redis in essentially an IoT device. And the overall overview of my presentation is basically, I'm going to give you a description of my irrigation system. Number 2 is how Redis came to be used. I mean, it wasn't contrived. There was a real need for it. The third point, and this is coming from an embedded person, is that IoT devices need to be managed more like a data center or an operation. They're getting to the point where it's hard to manage them just strictly as an embedded system. The fourth topic is the role of the graph database. The graph database played a significant portion in my system. And the fifth is I basically came up with a new IoT cloud communication system using Redis. And the sixth is basically, I've been working in an isolated environment, and not too many people have been using Redis in an IoT environment. And I want to talk about, maybe more open source projects in this area. So first of all, a brief description of our system. Tell you at least I built something. And this, around the year 2010, this was our 48 station Hunter system. It was it would run 48 valves, and it was programmed with knobs and dashes and buttons. And you had to do a very convoluted thing to program this thing. And it cost around $800, but it had no sense of configurability. So basically, this was the first thing I replaced. And I replaced it by essentially a system where I had individual sites, and I had a cloud computer, and the individual sites are standalone. Because basically, I designed it for the avocado community in California, and basically, some of the plots have phone lines, don't even have cell phones. At my farm, I have fiber optic internet. So basically, it's a function of the site. So the site has to be able to be standalone, and it also has to have the ability, where possible, to have cloud control. Like right now in my conference, I use my cell phone to manage my irrigation system and keep track of the farm operation. If I look at my edge device, I have one or more Raspberry Pi controllers. Originally, I started out with a BeagleBone Black. I have a sprinkler wire, which I use for RS-485 communication, and that's a serial line. And then I have satellite PLC controllers. They're programmable logic controllers. And the programmable logic controllers are the ones that actually interface with the actual hardware, turning stuff on, making measurements. In the Raspberry Pi, when I put Redis in, one of the important things is to put your Redis database on a USB drive, because the most important thing you want to do is preserve your SD card, because if you brick your SD card, your Raspberry Pi is dead. And this is what I use for my network control cables. Essentially 18 gauge sprinkler wire, 7-strand, and I I have power for the PLCs, I have power for the irrigation valves, and I have a serial bus RS-45 at 38 kilobits per second. And this is inside a PLC case. And basically, the white units are a PLC. The one on your the one on the, I guess, your left would be the main unit, and it has two expansion units. And basically, the cost of the PLC is roughly about $300. And the components are UL and FCC certified, so they're rugged. And this is the PLC deployed in the field outside. And I've had these units in the field for at least 5 years, and this is 2 feet of snow that happened 1 year in our house. And basically, the PLC survived the snow, they survived the 105, 110 degree temperature we've had. So some of the benefits of the new system is basically a web-based flexible irrigation controller. And then basically I have current sensors for detecting open wires, shorted wires. I have flow meters to detect leaks. And I have weather stations to set the weather time, set the irrigation times to match the actual evaporative loss. And what happened was, basically, before you had to go out and periodically check the lines. What happens now is the system's able to detect faults real time. And it actually can detect it probably more accurately than somebody walking the field for leaks. And right here, it shows an example of a 1/2 inch drip line. And a gopher chewed on the line. And it took about 3 weeks for the field people to find the leak, even though I knew there was a leak there and kept telling them there was a leak. These are just examples. The next leak picture is a 3/4 inch drip line that has been blown up. And what you see is a slight crack there. And that's about 0.5 gallon per minute excess flow. And essentially what happens is that leak would have never been determined by a manual system. And so the new system transformed our operation, so instead of having to every week check every line, that's about for our system, that's about 3 times, it's about $3,000. It's about 1/3 of the cost of my original hardware. Now, the next purpose is to tell you how Redis came to be. Basically, I'm an embedded programmer, never associated with databases. And essentially, I came up and was working on embedded Linux set-top boxes that had maybe 100 MIPS processor, very little flash. So you tended to put everything together. So basically what I had was, I essentially had a single Linux process, monolithic. And I was using a Mongoose web server, which was, for its time, was very respectable. But they changed directions. And now I have to bring in a Flask web server. Or it could have been a Node.js, but I'm a Python programmer. And now I got to get it into the irrigation process control. So I need a solution. So at this time period, there was only really 2 books on Redis. So I picked up the Redis cookbook, and I found out that they had a job queue. So I said, and it's persistent. I need a persistent job queue, because what happens is if I schedule irrigation events and I lose power, I still want the irrigation events still to be present. So what happened was, all of a sudden my monolithic program got divided up into very small fine programs. And the programs got changed from a big Lua C program into very respectable Pythons programs. And all the communication went through the Redis database. I found that it was very easy to integrate, and it was very easy to, to add new processes in. And I thought things, at this point, I thought things were, reasonably good shape. But what happened was, I was sort of not being systematic in the way I handled my data. And one of the things that this irrigation system has to do, it has to monitor the behavior of the system. I have to determine, it's not good enough to go out and turn on water. I have to determine when things fail. And things fail about 2 to 5 times a week, particularly, animals attack the sprinkler line, pumps break. So you get more and more log queues, logging. And you have to, or streams. And you have a lot more data just to make sure that the system worked. So what happened was, I had to transform the way I was looking at things. I tended to view Redis as a Swiss Army knife. In other words, it's a toolbar, it's a package, but it has a lot of tools in it that I can deploy in a very small package. And what made me change, what was very transformative was I read this book called The Art of Monitoring. And it was written by a DevOps guy. And, coming from an embedded background, I found it very enlightening in a sense that if you're doing DevOps, you got to have your logging plan, you got to have how you're monitoring things, and it's got to be set up front instead of just ad hoc doing it on your already completed applications. And I found that basically all the tools that are mentioned here, and there's a lot of tools, including Elasticsearch, that Redis could do these functions. Maybe not as good as the full tools, but for my data size, it was good enough. And that's where I get the concept of the Swiss Army knife, where I just load a module in, and I can add in functions. So what happened was, my Redis database gets transformed. The stuff that is absolutely needed, I have it on configuration files. But I have basically Redis control structures for job queues, RPC servers, and then I have a lot of logs or streams. And I'm starting to set this up. And what I'm also finding that basically, like the serial communications system needs streams because sometimes corroded wires break the communication. The Linux server in the Raspberry Pi needs logs because sometimes you have a process with a memory leak. So I'm just trying to say this structure kind of started to gel. And then basically, Redis database extracts very little resources. Like the process, like I have 3 processes in a Redis server. One's for evaporative loss. The second is for irrigation control. Third's Flask web server, and the Redis server. And you can see the Redis server really only takes about as much memory as one of my processes. And in my system where I have maybe 3 months worth of logs. I have about 41 or 42 megabytes of memory space, for Redis memory space, which means I have the smallest database of this conference, but it serves its purpose. There's power in little data, okay? The second thing I noticed, or the thing I noticed was that I needed to bring in a graphical database. And this was relatively controversial. A close friend of mine, when I talked to him about it, wouldn't speak to me for a week after I told him about this. And the reason comes in is that essentially I have to share keys and information among 3 or more processes, and sometimes they're not even on the same device. One may be in the gateway and one may be in the cloud. So if I store it in a conventional way, like if I store it in a XML database or a JSON document, I've got to know the structure of that data. And if I change the structure of the data, then it changes things. If I store it in a graph database, I basically only have to have a few query terms to find my information. If I change the graph, it's very easy. It doesn't really change the query terms that much. And somebody says, well, you're introducing a graph database. Well, Redis already has a graph database module. I just have to go to the configuration file and add it in. And there I'm good. And that's why I'm saying is that Redis becomes the Swiss Army knife in this operation. I did a sanity check. And basically, there's a Chinese electric utility company using a Redis cluster. And they basically had to design their keys based upon an IE standard. So I pulled they actually had this IE standard for dummies online, and I pulled the spec. And it's basically RDF and XML. And essentially what you're doing is you're modeling the system like a graph. You have bus bars and stuff. And basically that's a graphical database. That begs for a graphical database. And then basically the graph database is essentially the same as SNMP on steroids. The only difference was SNMP, you have to have funky tools and you cannot search it that well, where a graph database, you can search it. And if you look, you'll see that at the cloud database, and you have a lot of systems, the edge device is a subset of the master device. Is a subset of the total system graph. So if you change the graph on the cloud, it's easy to push it down to the edge device. Or if you change the edge device, you can come up and use graph operations to merge into the system. I found that very useful. I mean, I've been working, when I was a consultant, I was working for a company part-time in 1995. And we had IoT devices in thousands of retail stores. And there really was a clean way of allowing a customer, like a store manager, to change a system. Because if they changed the system, and then when you push down from the cloud, it wiped out his changes. So this way provided you a systematic way of allowing changes to be done on the edge and pushing back up. And then basically, when you have this is a typical, over on your right is a typical way I set my graph up. You have a system, you have a site, you have controllers, you have processes that are attached to the controllers, or you have like applications. Applications are different than processes or controllers because applications can be defined for various controllers. So what I found is that to construct this graph, it's better to be done as code rather than to use a dashboard to bring it up, because at least you have configuration control. Also with code, You can structure it in a modular fashion and put systematic checks on it. As a side note, on my YouTube channel, I noticed that at a Graphena conference, a lot of the dashboards, the organizers were using Python scripts to construct the dashboard instead of doing it graphically. And that's the same conclusion I have. So your graph is actually code that you put under configuration control. I mean, the thing that constructs the graph. And here's an example of, I have weather stations. And essentially, I have like here's your site. Here's your application node. And then you go down to the weather station node. And the weather station node has data packages. Example, it needs as a stream for the evaporative loss daily values, the rain values. And then it also has weather station relationships. So when I'm calculating evaporative loss, I'll use the graph to find out which weather stations I have. The graph will have the properties of the weather station, particularly URLs, tokens, stuff like that. They'll go out and fetch the values. And it works out fairly quickly. I mean, very few search terms, and you can have a modular number of systems. I mean, it's easy to find the information. And it makes sense, particularly when you have to add another weather station in relatively quickly. And the next point I want to point out is that Redis keys and the classes that access the data can be generated automatically. Because the problem I had was you got to have a key format. Well, a programmer of a programming team of one, at least I found it was hard to enforce discipline on key structures. And there's essentially two types of data structures I come on. One is data structures defined by the system graph, and I have data structures that are defined by user-generated configurations like irrigation schedules. And what I can do is essentially generate those handlers automatically, and I can generate the keys automatically. So I don't really manage keys, and I don't manage the code that accesses the keys, because they're done with a handful of, I mean, basically the stuff that accesses the Redis, the stuff that accesses the Redis data is really maybe 4 pages of code for the basic types you have. And then the last topic I want to talk about is a new form of IoT cloud communication. And that is, consider my evaporative loss calculation that's on the edge device. Essentially, from the Redis graph, I use a process to calculate the ETO. It has to be sent to the ETO history stream, and is sent to a moisture deficit hash table that the irrigation controller uses to control irrigation times. Also, the web server has to access this table, and it has to access the ETO stream. And that's an example of why the graphical data, it's an example of 3 processes talking, where you use the graph, you get your common data off the graph. Well, you could look at this process and you could say, well, generally this should be moved to the server, because you're managing a lot of URLs and access codes, and they're probably common for a lot of the nodes. So if I move it to the cloud, the graph database the cloud database is there. It's going to be on the graph's going to be on the cloud as well as the edge device. There's no problem there. The problem that I have is basically the web server and irrigation. The web server and irrigation controller do not have access to the data. So if there's some way of synchronization between the two, between the cloud and the edge device, then I can move this transparently. I can move this process fairly easy from the cloud, from the edge device to the cloud, or from the cloud to the edge device. And this is very, I was at the keynote today, and this is sort of very similar to what they're talking about with this CRDT type of thing that Redis is doing for other keys.
So you need an Avocado API?
No. What I need is I don't really. That's the point. I don't need that in a sense that I'm dealing with streams. I'm dealing with job queues. I'm dealing with RPCs, hash tables. I got very specific APIs. There's a finite number of tables. And I don't, so that the mechanism for one table versus another table, I mean, no matter what you use them for, the mechanism is there. And the friend that told me, that got mad at the graph database, told me that, let's suppose that you wanted to put deep learning or machine learning in. If you had a synchronization, you could move any ability of moving any data you wanted from the IoT edge device, you could move it to the cloud if you had that systematic method of doing it. So, like you're not going to run TensorFlow on a Raspberry Pi. So, if I had to do it myself, essentially what I would do would be, there's a common Redis data structure handler. And essentially, I would add a common handler to every time I made an access, it would send it over to the other side, and the gateway generates changes. It would publish it back to the cloud. We're talking very few amount of code, and essentially, you have a common data structure between the edge device and the gateway device. And you don't have to move this for all the data. Essentially, you can move it for what you really needed, but there's a mechanism. In other words, you're not writing specific messages for each individual piece of data. You're moving Redis tables. You're moving Redis data structures between the cloud and the edge device and vice versa. Also realize this data is changing over hours, and like my total Redis database is 50 dB. So basically, you're not moving a lot of data, but I'm changing the way that I talk, in a sense that I have a systematic way of introducing cloud functions to the system. And basically, the commands to do this are probably less than 30 to synchronize. Like update stream, update hash element, push job queue, pop job queue. And essentially, they're tied to the data structure handlers. They're not tied to the application code. And and finally, I'm lacking one thing. And that is, if you really want to create hate and disconcern, go to an industrial farm meeting and mention open source. Basically, the systems are dominated by vertically enclosed systems. What you can do in the cloud, what you're doing in the IoT space that you have here, there's very little freedom for agricultural, and even SCADA systems to do. And what I'm suggesting is that more IoT systems using Redis, open source, explore this space and open it up so we get the same creativity that you guys in the, in the IoT community get. I mean, you guys in the web communities and the DevOps guys have. And basically, we spent 4 years building this and exploring it and the use cases, and we constructed systems, and we're willing to offer our experiences in helping build this community. So that's where I am, and I've covered a lot of information, so if there's any questions, please ask. Yes, sir.
So I'm really, really impressed with the work. I'm really, really impressed with the work you've done and the talk you delivered. I'm stunned, actually.
So how many avocado farms are using this now?
Basically, if I wanted to lose a friend, I mentioned this to the avocado community. Because what happens is, if I mention it to my neighbor, he mentions it to the person taking care of his crop. And what happens is the person that takes care of his crop makes money by farming people out to take care of his farm. Anything that reduces labor cuts into his profit. I took it to the head of research at the Avocado Commission. I spent 1.5 hours with him. I offered to put it on a ranch, on his experimental farm. He was all gung-ho. He went back to the home office. He got shot down because commercial companies pay for advertising spots. So basically, I mean, if you really want to lose your friends, you start talking about this. That's why I'm talking about it here.
So the issue is you're about 10 years ahead of the industry. You're too smart for your neighbors, okay? I'm from the tomato capital of the world, Leamington, and I can see immediately how valuable this is, and I'd be happy to work with you on promoting and improving this. It's amazing.
Like you see here, the Port of San Francisco will not let me stand to give this talk. So I've had some health issues, and I cannot, physically sell. I'm not here to sell anything. I'm here to promote a technology. I'm here to promote my research. And I'm telling you that if I pick, I'm an army of one. And I'd like to get other people to come in and share this and push Redis down into this community and show that, hey, there's a lot of application. So I'd be happy to help you.
Thank you.
But I also tell you that don't expect any favors. Yes, sir.
Do you have any insight as to using maybe soil sensors or cameras to?
I can't hear you, sir.
Oh, sorry. Do you have any insight as to using sensors or cameras to know when the avocados would need water?
The avocados have what on them?
How would you? Have you looked into using soil sensors or any cameras to sort of supplement your data set?
First of all, I do have soil sensors in. They're usually, the most reliable ones right now are gypsum. They cost about $34 a piece from a company in Riverside, California. I need to integrate them in. The only problem I have is my soil's a foot deep, and it goes right into bedrock. I'm on Southern California avocado farms on 45 on slopes for frost. We're on the edge of, we're on the pushing edge of growing avocados in California, at least in the southern part. So one of the problems I'm having is integrating that into getting good soil recordings on that. The model is basically You have 3 feet of 3 feet of soil. You put your sensors in about 8 inches, and then there's a curve of when you water, you don't. I found that the ET0 data, or evaporative loss, or the Pendleton equation, works pretty good for me. But I'm going to put soil sensors. Now cameras, cameras are more used for security. There's a lot of avocado theft. And basically what could be done is, my use, the free time use on my system is about 5%. So I got memory space to put a security system in and whatever. And that's the purpose of with the Redis system, it's easy to bring in modules so I can add the security in or whatever. Any other questions? Well, thank you for your time and effort. Appreciate it.